Hey, welcome back to our LeetCode interview series with a focus on Facebook questions. These are the most frequent questions according to LeetCode. My premium has run out. I cannot afford a new one, but one day we will get back into LeetCode Premium. But today we're going to be tackling apparently a very common question called Basic Calculator 2. I think the calculator series is very common in a lot of companies. So we're going to be tackling this one today. So basically what we're going to be doing is that we're given a string s, which represents an expression, evaluate this expression, and return its value. The integer division should truncate toward 0. Okay. You may assume that the given expression is always valid. Sorry, there's a loud bird outside my window right now. All intermediate results will begin in the range of negative 2 to the power of 31 to 2 to the power of 31 minus 1. All right. You are not allowed to use any built-in functions which evaluate strings. Okay, so we cannot use .eval. Pretty straightforward. So we're given a string. Yeah, that's about it. Basically, the idea would be if we come across an empty space, we just ignore that and move forward. So there are a few things we need to do. First up, this is going to be, I guess, a stack question because we have to keep track of the numbers and also the operands. So whether or not we add, subtract. If it was adding and subtracting, it would be very straightforward. But with the addition of multiplication and division, we have to keep track of the previous sum. So we have to, just use a stack in order to, keep track of this 2 here without having it as a 5. So it would be 2 times 2, which would be 4 plus 3, which would be 7. So that is the main trick that we need to tackle. So we'll start off by doing that. So we'll say let our stack equal an empty array or empty list, depending on which language you use. Next up, we need to keep track of, I guess, the current number we are on. So we could have double digits or triple digits or quadruple digits. So it could be 500 or 200, 20 or 31, etc. We need to be able to keep track of that. So we'll also call this, so let our number be equal to 0. We're going to start at 0, obviously. And then we're going to start off with an operand. So what is our operand? So call it operation, actually. We'll just call it op. So our op will be keep track of if the most recent operation has been a addition, subtraction, division, or multiplication. And of course, we're going to start off with a positive number. So, or I guess we'll change it if we get to it. We're going to start off with positive, so addition. And then what we want to do is loop through this string. So, for example, say for, let our I equals 0. I is less than or equal to string.length. I'll talk about why we use less than or equal to, because we want to be able to get to the end of the string and not ignore it. I don't want to keep ignoring it and then add another line at the end of the loop just to check if there's a remaining value in the num. So we're just going to go ahead and less than or equal to it, and we'll add another piece of information, and then we'll increment our I. So here we go that. So first up, what we want to do is check if this is an integer. So we're given string versions of these numbers. So the ASCII codes will be within a range. So what we first want to do is check if this ASCII code is between the string version of 0 and the string version of 9. So if our string at I is greater than or equal to the ASCII code of 0 and the string version of the string at I is less than or equal to the ASCII version, or ASCII, the string version of 9, the ASCII code of 9. What we want to do is we want to update our num. So num would now be equal to num times 10. So we're multiplying by 10 to move it over a spot. And then we also want to add our new number. But in order to do this, we also want to parse our integer. So parse int at s of I. So we want to get the integer version. We don't want to get the string version of this. And then, yeah, that's about it. From there, we then want to do another check. We want to check. So this will take care of items that are string versions of numbers 0 through 9. And then we also want to check for operands. So those would be addition, subtraction, multiplication, and division. So we'll do another one. So if we do an array, so if we have our plus, we have our minus, we have our multiplication, and we also have our division. So if this includes, so we are going to search through this array to see if it includes, of one operation, there's only 4 in there. If it includes what? If it includes our s at I. So this is checking if s at I is one of these. That is 1, or another thing could be if our I is equal to our string dot length. So if we get to if we break out of the string and we need to account for the last integer that we have seen, then what we want to do is go through our information. So if s at I is equal to addition, what we want to do is just push that element to the stack. So we say stack dot push, and we're pushing our num. So same thing with subtraction. So if our s at I, well, I guess we're not using s at I, we're using our operation right now. So if our operation is plus, because we are looking back, if our operation is equal to our minus, what we want to do is say stack dot push, because we want to get the most recent operation that we saw, not the current operation we are on. So for example, when we hit this multiplication here, we need to look back at this one and then add the number that we had to this 3. And then we're going to be pushing our negative number. Push our negative number. And then if our our previous operation is equal to multiplication, this is where the fun stuff happens. What we're going to do is say stack dot push, but what are we pushing? We're pushing the previous number that we kept on the stack multiplied by the current number. So basically what we're going to do is say stack dot pop, get that, and we're going to multiply that by our current number. And then same thing with division. We're going to have to pop an item from the stack. And of course, it said we need to truncate it, so we'll handle that. So if our OP is equal to a division, we want to say stack dot push, and what are we pushing? What are we pushing? We are pushing our math dot truncation, math dot trunk of what? We're saying stack dot pop divided by our current number. So we have to first truncate it and then push it to the stack. After we have popped, let me put our parentheses there. All right. And then after we make all the way through, we need to update our operation to our new operation. So that'd be at s of I. And then we also need to reset our num. So num is back to 0 because we used the num up. We added it, subtracted it, multiplied it, or divided by it. And then we pushed that new number to the stack. Let's see. And then easy peasy and squeezy. All right, and then we get to our for loop, and then we're done. So at this point, all we need to do is we have a stack. I'll go ahead and show you what our current stack looks like. So console log our stack, just to show you. Let's run it. It's gonna fail, I know that, but we can look at our log. So we have a 3 and a 4, and we are looking for a 7. So we have our 3, and then a 2 gets pushed on, and then we come across this multiplication sign. So we need to pop off the previous 2, multiply it by 2, it's a 4, and then push that on, and that's how we get this 4 here. So what we do is just do a simple reduce. So here we go, return stack dot reduce, and what are we reducing? We're reducing A and B, where A and B are added together, and we have starting out with 0. So I'm going to go ahead and run it, make sure it works. I hope it works. They all work, and I'm going to go ahead and submit it. And let's see, does it work? Okay, great. We are better than 75, almost 75% of people. Our memory is not good, but memory's cheap. Runtime is not. I prefer runtime. That's just me. So yeah, that is how we do calculator 2, which is problem number 227. And according to LeetCode and people who have participated in previous Facebook interviews, say that this question is very common. So make sure you study up. If you have any questions about the logic in this that I did not sum up for you, please let me know. So basically, space complexity, O of n, time complexity, this would be an O of n operation because we have to go through every element of the string. So O of n being the number of characters in S. So worst case scenario is just a full line of numbers, no operations. Or yeah. So pretty straightforward. If you have any questions, put them below. I'll do my best to help you. And yeah, happy coding. Stay strong.